Welcome to Something to Talk About from the Bainbridge Island Senior Community Center. We do these programs several times a week. You can find out what's coming up by going to biseniorcenter.org/calendar. And you can watch previous programs by going to youtube.com/BI Senior Center. We are grateful for the sponsorship of Fieldstone Communities of Bainbridge Island to support these programs. Fieldstone offers assisted independent living and memory care up on Rolling Bay. They also have day stay and respite care programs, and they're actually offering free lunches in their lovely restaurant. If you just give them a call and set up in advance, call 206-594-1010. Check out their website at fieldstonecommunities.com or email Ashley C at fieldstonecommunities.com. That's ASHLEYC at fieldstonecommunities.com, and schedule a tour or lunch. Also, we'd like to acknowledge that we are meeting on the ancestral homeland of the Puget Sound Coast Salish people, specifically the Suquamish people, the people of the clear salt water. We are grateful for their stewardship of these lands and waters, and we learn from them to this day and are grateful for their helping us do that. Today, we're going to talk about heat pumps and what they are, how they work, how you can afford one, and why you might want to do that. And to help us with the conversation, Anne Lovejoy, who recently went through this process herself, is here to start off the questions. And we also have a couple of other folks here. We have Maria Dozeman from Puget Sound Energy, and Rodney Agee from Advanced HVAC, I believe is the name of the company. And so thank you. Oh, and John Davey from PSE as well. So with that, I'm going to hand over the questioning and answering. But if you have any questions or answers, feel free to pop in with them when you want. Anne.
Thanks, Reed. Yeah, this, like so many people, this winter, my heat pump failed. And it turned out that it was from 1991, so maybe that wasn't the biggest surprise in the book, but it really was. It put us at a big disadvantage. And like a lot of people, I didn't really know what to do next. And I got several bids from different companies and got very, very different responses and different kinds of suggestions and recommendations. And it was kind of bewildering. And one of the reasons I asked Rodney here is because when he came to my house, he was the first person who actually made me read all the information and said, it's your responsibility as a consumer to know what you're looking at, to know what you're buying. And honestly, I tend to kind of, it fits in my kitchen, it's good or whatever. But we have to look a little harder and a little deeper because some of this technology is really amazing. And learning how it works and how it's going to best work for the layout in your house, that's really important. And I appreciated very much too that Rodney, you encouraged me to really think about like what our needs were and how they might be best met. So, do you want to say a little about like what you tell people when they're thinking about, if somebody calls you and says, I need a heat pump, can you kind of walk us through some of the decisions you might make and how they actually work?
I can absolutely do that. I could probably take up this whole meeting talking about HVAC systems and heat pumps. But let me start introducing myself. My name is Rodney Agee. I've actually been in the HVAC industry for 19 years now. And that entire 19 years has been with advanced heating and cooling. So I know the advanced way, and also just from what I've learned from being in the trade. The HVAC industry is a licensed trade. Whenever you're looking at a contractor to do HVAC work, definitely investigate the contractor that you're hiring. Make sure that they are licensed, insured, bonded, and that their employers are also trained and licensed. In the HVAC industry, there are standards, there's codes, and there's regulations. So all of these things should be taken into consideration when you're hiring a contractor. We're here to talk about heat pumps today, but first let's talk about Bainbridge Island and the different types of HVAC systems that are most common on Bainbridge Island. The first one we'll talk about is the basic electric furnace. An electric furnace is a toaster oven. Many of us have toaster ovens in our home. It's a electric coil. It gets red hot, air blows across it, and it heats your house. The electric furnace is technically 100% efficient. For every kilowatt you spend on your electric furnace, you get 3.3 BTUs out of it. There's no waste involved with an electric furnace, but those kilowatts add up. The heat generation of an electric furnace can be very expensive. If you went out and looked at your meter while your electric furnace is on, you'd get dizzy watching it spin. But it's a very reliable system. They can last 30 years. The downside, you don't get any air condition. And we definitely are wanting air condition more and more. The second common system is a propane furnace. There's no natural gas on Bainbridge Island, so if you wanted a gas furnace, you had to go with propane. Propane's getting very expensive, and the price fluctuates based off of oil. Another aspect is that we're experiencing climate change, and carbon is a big push to decrease our carbon footprint. So not only locally in our state, but also federally, we're trying to eliminate carbon producing appliances. So there will come a time that you could not replace a fuel furnace like a propane furnace. With a propane furnace, you can add air condition or a heat pump. And when you add a heat pump, we call this a dual fuel system. So I'm not sure if y'all have heard of dual fuel. What that means is you're using electricity for the heat pump and you're using propane for the furnace. So that's why it's called a dual fuel. The topic of today is mainly about heat pumps. The big difference about heat pumps, when we talk about the first two options, electric or propane, electric and propane are generating heat. So they're using a fuel to create heat. A heat pump is exchanging heat. So we're not actually consuming a fuel to create heat. We are exchanging heat from outside. We're bringing outside heat and we're bringing it into the home to heat the home for heating purposes. And when we're in air condition, we are taking the heat out of your home and sending it outside. So a heat pump is a heat exchanger. Heat pumps can be very efficient. With variable speed technology, they're up to 200% more efficient than electric furnace. So for example, for every kilowatt you spend in electricity, let me back up. I said that it's a heat exchanger and that it's very efficient. There are motors involved. There's a compressor and there's a blower motor. So electricity is used to do the heat exchange. So you are using electricity, but the basis is we're exchanging heat, which makes it a lot more efficient. Back to the efficiency, they can be up to 300% efficient. So for every kilowatt that you spend, you can get up to 9.9 BTUs out of that kilowatt. So definitely a lot more efficient than just a straight electric furnace. Excuse me. So that can, in the end, mean significant electrical savings. I don't want to overwhelm too much. I actually have some videos to present.
How does a heat pump work? All air conditioning systems, including heat pumps, rely on the refrigerant's pressure-temperature relationship. When a refrigerant evaporates or boils, it absorbs heat at a very high rate, as is the case with all liquefied gases. Since refrigerant has a lower boiling point than most liquids, we can easily manipulate it so that the only heat source needed is room temperature air. We can control this boiling point by altering the pressure placed upon the liquid. Now, let's take a look at the operation of a common split system air source heat pump. In the summer, the compressor, the heart of the heat pump, receives cool, low-pressure refrigerant vapor. It then pumps this vapor into the high-pressure side of the system. This hot, high-pressure gas now travels through a routing valve known as the reversing valve to the outside coil, which functions as the condenser. In the condenser, the heat is removed from the refrigerant by the outdoor fan, causing the refrigerant to condense into a liquid. The liquid refrigerant now bypasses the first expansion valve by means of a one-direction valve known as a check valve. The refrigerant, now cooler but still under high pressure, travels along the liquid line to the indoor unit where it is forced through the second expansion valve. This valve partially restricts the flow of refrigerant, creating the needed decrease in pressure, which allows the refrigerant to start evaporating. As the refrigerant evaporates, it absorbs heat from the passing air. In addition, the cold evaporator collects moisture, which provides dehumidification for the home. The refrigerant then travels back to the compressor, where the process is repeated over and over again. During the winter mode, the reversing valve reroutes the refrigerant path, thereby making the outside coil function as the evaporator and the indoor coil as the condenser. The heat is absorbed from the outside air by the evaporator, then brought inside and released by the condenser to heat the home's air. Also notice the outdoor expansion valve is now active as the indoor expansion valve is bypassed. This is a very efficient and cost-effective method for heating the home. There is one inherent problem, however. In order for the evaporator, now outside, to absorb heat, it must operate at temperatures lower than the outside air. This very low operating temperature allows ice or frost to accumulate on the outside of the evaporator. The remedy? The defrost cycle. As the defrost cycle is initiated, the reversing valve switches the refrigerant path back to that of the summer mode. This allows indoor heat to be transferred from the inside airstream to the outside coil, thereby melting the accumulated frost. To speed this process up, outdoor fan operation is terminated throughout the defrost cycle. Also notice that the indoor airstream, now being robbed of its heat, becomes very cold, which is not a desirable condition during winter. To compensate for this condition, the auxiliary heat is activated for the duration of the defrost cycle. After a few minutes, the outdoor coil is frost-free and the defrost cycle is terminated. And that's how a heat pump works.
That video was to explain the process, a very complicated process. And I wanted to share that video because that was about as basic of a demonstration as I could come up with for how a heat pump works. And that can be confusing to somebody who doesn't understand heat pumps. But I kind of wanted to share that it is complicated and that it's not easy. There is a lot of technology and science. But I also wanted to share that video because some of you may already have heat pumps. And when you're told that your heat pump has a problem, some of those parts that you heard are some of the big parts that can fail: the compressor, the reversing valve, the metering device. So all heat pumps have these. And know that when you hear those parts mentioned to you that you have this problem, that it is a major component in the refrigeration process, and it can be significant to your system. So the main thing to focus on heat pumps, the process is thermodynamics. We're taking a liquid, we're boiling it, turning it into a vapor. We're taking the heat from that vapor that we absorbed and we're exchanging it And once we cool that vapor back off by releasing that energy, it turns back into a liquid. So the heat pump process is liquid, vapor, liquid. And that's really what we're doing is just changing state of a gas and using the outside ambient temperature and your home to do those exchanges.
Now, it looks like some of the newer technology makes this a lot more efficient. So you might have an older heat pump like I did that wasn't really functioning anywhere close to what a new one could do. Is that right?
Absolutely. And I do want to get into that as far as technology and where we're going. In the process of if you're deciding that it's time for you to get a heat pump, it's time for you to change to a heat pump, or to even increase the technology to the variable speed, the high tech, high efficient technology, there's many things that we have to take into consideration. And the first one is your home. So not only your home, but also your current ductwork.
Yes.
These are things that we have to take into consideration to determine what type of heat pump we should put in. So the next video I wanted to share is that significance about duct sizing, restriction, and filters, what kind of impact a filter can have on your system. So if I could, I will share that one now.
Static pressure. It might sound harmless, but it affects the entirety of your HVAC system. In this video, we'll discuss what it is and how to avoid it. Hi, I'm Roger with Fire and Ice. Over the years, our service techs have gone out on a call to repair a system that is completely shut down. They later find the problem to be high static pressure due to a clogged furnace filter. In this video, we'll go over how a furnace filter can cause high static pressure and discuss what is static pressure, how does your equipment and ductwork affect static pressure, how do filters contribute to static pressure, when to change your furnace filter, and finally, what can you do right now? What is static pressure? Let's begin and determine what static pressure is. Simply put, it is the resistance experienced by air as it passes through your HVAC system. It's a lot like blood pressure in your body. Too much static pressure can cause strain on your system, reducing its performance and can result in wasted energy. If left untreated, it can result in premature failure of the system. The best way to maintain optimal static pressure is to have properly sized equipment and ductwork installed correctly in your home. Additionally, regularly changing your air filter will help maintain static pressure levels. How does your equipment and ductwork affect static pressure? In an HVAC system, air is collected from the home by a blower motor inside your furnace, conditioned and then recirculated throughout the house. When your HVAC system is dialed in, air is able to move freely throughout the ductwork and into your home with optimal static pressure levels. HVAC manufacturers have a preferred range for static pressure levels within their equipment. When static pressure levels fall above or below that range, damage can occur to your HVAC equipment. There are a number of contributing factors that can cause increased static pressure, such as the size of your furnace has a lot to do with static pressure levels in your home. An oversized furnace can be too powerful and can cause high static pressure inside your ductwork, while an undersized furnace won't be able to move enough air throughout the system to keep you comfortable. Second is the size of your ductwork. If the ductwork in your home is too small, the air moving inside can become too restricted and cause high static pressure. Conversely, if your ductwork is too large, the static pressure becomes too low and can rob you of your comfort. Third is the installation of equipment and ductwork inside your home. Improper installation or too many bends and turns in your ductwork can negatively affect static pressure levels. Fourth is a dirty or clogged air filter. The best way to maintain optimal static pressure levels is to have load calculations performed to determine the correct size system for your home and to determine any modifications that your ductwork may need. In fact, a lot of the estimates we provide here in Central Ohio include the replacement of return air drops because past HVAC systems were undersized. Having a qualified HVAC professional determine the right size for your home is critical in maintaining optimal static pressure levels. How do filters contribute to static pressure? A furnace filter is designed to remove debris from the air. As time goes on, the debris builds up and restricts the amount of air that is able to flow through the filter. Restricted airflow can cause an increase in static pressure. This airflow backup makes your system work harder and in the short term cause pockets of hot and cold spots in your home from a lack of airflow coming from the vents. Noisier operation as your system works harder, longer run times resulting in higher energy bills, and overall less comfort in your home. Long-term effects of high static pressure can result in leaks in your ductwork and a significant reduction in your system's lifespan. When to change your furnace filter? All filters come with a recommended replacement schedule on their packaging. Some are as early as 30 days, while others need to be changed once a year. It's recommended that you stick to your filter's replacement interval. Otherwise, you may experience an increased static pressure in your system. However, in some instances, you may need to change your filter more often to maintain proper airflow. For example, pets are known for shedding, and dander can cause filters to need replaced sooner. During allergy season, the increase of pollen in the air may cause your filter to clog quicker. Smokers who smoke inside may find themselves needing to change their filters more often. Particulates found in smoke can build fast in filters. Lastly, the frequency your system runs will also increase the use of your filter. Continuously running your system will cause your filter to need replaced sooner.
So it's not always just about the home, but it's also about your existing ductwork. And we're changing from one system to a different type of system a lot of times, again, electric furnace or gas furnace to a heat pump. And I wanted to bring up that static and that resistance issue because if we go back to the liquid vapor liquid process and that a heat exchange has to occur to make that change of state. If there's restricted ductwork, that vapor may not turn back into a liquid, therefore causing more strain on the heat pump equipment because that change of state did not occur. So this is one of the things that we have to consider when we're sizing equipment, putting in equipment, and also, most important, your filter. Again, he did say that filters have timelines. Typically a 1-inch filter, which is the most common in our homes, should be changed about every 3 months. And like he said, your lifestyle can have a big impact on that, on how frequent it should be changed, how many people are in the home, pets, having windows open, allowing in outside dust. All of these things can affect your filter. And the best thing is to get a baseline, check it monthly until you get a baseline to know how often you should change it. If you get that baseline, check it 1 month, you know what, it doesn't look that dirty. I'm going to check again next month. And once you get to the point where a filter comes white, when they're dark gray or starting to collect fuzz that you could pull off of the filter, it's time to change your filter. So get that baseline and then just set that as your timetable. Again, some filters can last up to 6 months or even a year. And usually those are thicker filters, up to a 4-inch filter. Those can last 6 months plus. The main thing is your lifestyle. No home is the same. We all treat our homes differently. We all have different pets or things that we bring into our home. So do that analysis of your system to determine how often you should change your filters. The next thing is now we're going to start talking about types of heat pumps and the efficiencies of heat pumps and the change in technology of what's out there. The main options in heat pumps are what we call a single stage, a 2-stage, or variable speed. So this next video will talk about those 3 different types.
Option has the simplest form of technology. It's lowest in price, but it's also the lowest in value. Almost every part of these single-stage systems can be repaired with universal parts, meaning you don't necessarily have to go through the distributor to get the replacement part. Single-stage motors, compressors, control boards, pressure switches, and gas valves are everywhere and readily available. very likely on your technician's van right now. Two-stage systems have better technology. They run more efficiently and control the temperature in your house without fluctuating as much. The main feature of a two-stage system is that they all typically run at around 70% capacity in the first stage and 100% capacity in the second stage. These systems will run the majority of the time in the first stage, which is where you really start seeing the money savings. Two-stage systems are great for two-story homes that have two thermostats or zoning. These systems can be set up to run in first stage when only one floor is calling for air. The second stage will only come on when both zones are calling for air. When it comes to salespeople pitching you systems, a lot of them will say, oh, but our system is an 18 SEER, not a 16 or a 17 SEER like the other brand. I tell my customers not to get too caught up in SEER ratings and focus on the technology. Any two-stage system is going to outperform a single-stage system. And when you're comparing two-stage systems, the minuscule savings that you're going to receive by going with an 18 SEER two-stage over a 17 SEER two-stage is trivial. No matter what brand system you buy, two-stage motors and compressors needing repair will have to be ordered from the warehouse near your town that distributes them. There aren't a lot of universal parts available for two-stage systems. Now, capacitors, contactors, and some other parts are universal. But with higher-end equipment, you see safety components like special pressure switches to protect the furnace or air conditioner from damaging itself. And these parts have to come from their factory. With Train, Carrier, Lennox, all the way down to Goodman and York, I've never had a hard time getting these replacement parts. And I can't really say that I've seen any huge price difference in the cost of these parts from brand to brand. At the most, we've had to wait 5 to 10 business days for a part to come directly from the manufacturer. There are always exceptions to this, but honestly, it would be the same for any brand. Remember how two-stage systems have a 70% and 100% capacity? Variable speed systems can adjust their capacity levels from about 25% to 100% in 1% intervals at a time. These systems can keep your home within a half a degree of the temperature that you want it. These are the quietest systems too, because they typically run at a lower speed, they require less energy, and they create less noise with less vibration. There are a variety of SEER ratings when it comes to variable speed systems. Once again, I would encourage you to focus on the technology and not the SEER ratings claiming higher numbers. Systems you install today will always be way more efficient than those of 20 years ago. All of these variable speed systems have Wi-Fi capabilities and are communicating systems. When it comes time to repairing these variable speed systems, only their proprietary parts are going to work. With such intricate technology comes priciness and a higher learning curve for who can actually make the repair for you. Train, Lennox, Carrier, and all the other brands with variable speed lines will usually only make these parts available to their most respected dealers of those brands. The skill that it takes to handle inverter type systems is next level.
What does that really say about the three different types, the single stage, the two stage, and the variable speed? The single stage is, again, 0% or 100%. It's on or off. The installation, the cost of the equipment is cheaper up front. All the parts are usually easy to replace. The downside is that technology is changing. With the push for the more efficient equipment, all the way to federally, the market is heading towards variable speed. I can relate it to a car, a stick shift. I mean, when's the last time anybody drove a stick shift? I mean, some of us, we miss the stick shift, and that's what people are going to say about a single stage piece of equipment. You know, oh, it was easy to operate. You know, it did what it was supposed to do. But technology is just surpassing it. And if you wanted your stick shift worked on today, you may have a very hard time finding somebody who could work on it or had the parts to fix it. And that's where we're heading. 10 years from now, a single stage piece of equipment could actually be more expensive to repair than a variable speed, just because the parts aren't going to be as readily available as they are today. One more quick video on the difference in the single stage versus the variable speed to kind of put it hopefully in a little bit more layman's terms for you.
The speeds are single stage, two stage, and variable speed. First, a single stage system operates at either full capacity or is turned completely off. Trained single stage units are affordable options initially, but may lead to more energy use as the unit switches on and off to maintain the temperature for ideal home comfort. Second, a two-stage system controls the temperature in your home more accurately than a single-stage system because it operates at a high and low setting, and therefore uses less energy and is more efficient than a single stage. This system is ideal for homes with many rooms or temperature fluctuation. Two-stage systems are also more efficient in removing moisture and reducing humidity in the home. Lastly, a variable speed system is the most efficient and quiet system. A variable speed system has the capability to maintain the highest level of temperature control and provides optimal humidity control. This system is ideal for homes that experience temperature swings and/or high humidity. This option has more upfront costs, but can offer a more energy-efficient solution.
The main thing there was the temperature variations. Most systems, your thermostat is the brain of your system, and the thermostat determines when a system should turn on and when it should turn off. Our thermostats, most of them have what we call a dead band. So you may have your thermostat set to 70 degrees, but there's a plus or minus. So your temperature can range -2 degrees. So it could get all the way down to 68 before your system kicks on. And then it could pass your setting by up to half a degree to a degree before it shuts off. So that's the big temperature swing that it's talking about, especially with a single stage piece of equipment. So it can be doing what we call short cycle. It could be on and off a lot. It could turn on, meet demand, and then turn off, but within 10 minutes need to turn back on again, which creates inefficiency and it creates more wear and tear on your motors. On and off motors shortens the lifespan of a motor. You could ask any engineer, they would prefer that a motor came on once in its life and turned off once in its life. That would be their preference. So again, a single stage motor with the on and off cycle, there are a lot more failures with those types of motors. With the variable speed motors, we're trying to create longer run times, so the on and off cycle occurs a lot less. So the next thing to talk about is your home and bringing in a contractor to replace your HVAC system and what should be considered with your home when determining what equipment to put in. It's very important to do what we call a heat load calculation on your home. Your home is always wanting to equalize with the environment, such as anything. A cup of coffee sitting on the table is going to cool off. It's because it's wanting to equalize with the environment around it. Your home is doing the same thing. If it's 30 degrees outside and it's 70 degrees inside, it is doing everything in its power to equalize at all time. So your home is absorbing the cold from outside, and outside is absorbing the heat from inside your home. So what we need to determine is, how do we beat it? How do we beat the environment that is trying to come into your home? And that's what we call a heat load. So if it's 70 degrees outside, that is what we call an equal balance, because most people aren't wanting it hotter or cooler than 70 degrees. So there's no demand on the home. But as it gets cooler outside, let's say it's 47 degrees outside, now we've created an imbalance. rebates, and we need to know how many BTUs to put into your home to maintain that 70-degree temperature that you desire. Now, as it gets colder, that demand increases. So if it's 70, there's 0 demand. At 47, it's a different number, all the way down to our lowest temperature, 17 degrees. We're going to be looking at a different number. Again, ranging anywhere from you need 0 BTUs up to you may need 60,000 BTUs to maintain your temperature. So let me give you an example of what we do as a heat load calculations. So this is an example of a heat load calculation. As you can see, the outside temperature is always trying to penetrate into the home, and your heat from inside is always trying to leave the home. So the idea is we take the entire square footage of the home and put it into a software program. We can annotate where there's windows. Windows are big culprits for heat loss and gain, heat gain during the summertime. We can calculate what the insulation ratings are in your walls, in your crawl space, and in your attics. We can even determine how important it is based on which way your home faces. Does it face north, south, east, west? Do you have shading? All of these things can impact how much heat or cooling your home needs. So based on these calculations, this example showed me that when it's 17 degrees outside, this home needs 23,000 BTUs to maintain comfort. Also, when it's 90 degrees, this home only needs 14,000 BTUs to keep it cool. So quite a significant difference on our heating load versus our cooling load. So those are things that we have to take into consideration. Now, once I have this information, I can do what we call a balance point. And this is the magic of sizing your HVAC equipment. So this blue line is your home. So when it's 70 degrees, you don't need any heating or cooling. But when it's 35 degrees, you need about 17,000 BTUs. When it's 17 degrees, you need about 25,000 BTUs. So we know that's what the heat load of the home is. Now what I can do is take different equipment and base it off of its performance. So on this example, I actually have, this is a single stage piece of equipment, is this line. And this line here is variable speed. The real thing is that they are both rated exactly the same. This is a 4-ton unit and this is a 4-ton unit, but the performance of each is drastically different. So for example, this single stage piece of equipment can maintain the comfort of your home until it gets to about 32 degrees. So about 32 degrees, the heat pump needs assistance to keep the home comfortable. So this little triangle right here is what we call our supplemental heat demand. So when I size your equipment, if the heat pump can only keep you comfortable down to 32, but we have the potential of being 17 degrees, this tells me how much supplemental heat I need to add to your system to keep you comfortable. Now, if we look at the variable speed system, so again, they're able to perform the same amount of BTUs, but this one is able to do it all the way down to 17 degrees, all with the heat pump. This triangle, again, is how much supplemental heat you need. But again, we're only 2 degrees off 17. So I only need a bare minimum of supplemental heat. So that is the biggest difference between a single stage piece of equipment and a variable speed piece of equipment, because all of this extra heat that you're going to need is going to be that toaster oven. It's going to be the expensive heat right here, where again, the variable speed doesn't need very much at all. Another line I wanted to show about the variable speed. Again, this is the single stage. So when it's 55 degrees and you need heating, the single stage piece of equipment is going to give you 100% of what it can do. So it's going to give you all of this extra heat that you didn't necessarily have the demand for. You only had a demand for this much heat. The difference in the variable speed is that it can range in capacity anywhere from 25% to 100%. So even though it has the ability to produce 42,000 BTUs, but at 55 degrees, you only need 8,000 BTUs. The variable speed heat pump will only give you 8,000 BTUs. Then as it gets colder, the variable speed system can increase its capacity. So again, by not being 100% all the time, that is also energy savings by only providing what you need. So that is pretty much it on heat pumps. Any questions up to this point? Am I consuming too much time, and do I need to turn this over to somebody else?
Oh, thanks, Rodney. This is great. I think one thing I know people are kind of wondering is like, how do they decide if they need a mini split or ducting? But you've already sort of covered some of that, right? If you already have ducts, you're probably better off with a ducted system, or it's the layout of the house that might require a certain, is that right?
That's correct. A lot of homes today are being designed with nothing but ducted systems or ductless heat pumps. It really comes down to cost at that point. The real advantage of a ductless system is that you can truly zone your home. Your living room can have one ductless system in it, and your bedroom have another, and your home office have another. And maybe you don't like sleeping in a bedroom that's 70, you like it 65, so you can keep your bedroom at 65. The office, you know what? I like it warmer in the office. I want it 70 degrees. In the living room, maybe you're having guests and there's a lot of people and creating a lot of heat. Oh my goodness, it's the middle of winter, but I need air condition. And you can turn on the air condition. So that is what ductless units are doing, is they're customizing to people's individual needs. Now, when we are talking about an existing home with existing systems and no new construction, we're basically remodeling your home when we try to put in ductless systems after your home is already built. So it can be a very invasive process to do ductless systems in finished homes. It's not to say that it can't happen or that we haven't done them. We have, but it can be very invasive. A lot of things can be unsightly because again, there's mechanical fittings that have to go from heat pump to indoor unit, and we have to get from A to B. And a lot of these things are exposed on the outside of your home. So there are a lot of considerations to take into effect when you are switching from a ducted system to a ductless system in an existing home.
And another thing I noticed when I needed a heat pump, I got a number of bids from different companies, and they ranged from about $10,000 up to about $35,000. Pretty big range. And I'm guessing now that the low bid was probably that single, uh, what did you call it? The single state or
Single
something?
stage, yes.
Yeah.
Single stage.
And that the highest, but it was interesting to me that as I got higher, there wasn't really all that much difference except maybe technology and And I noticed that some of the Asian built systems were maybe more reasonable and had very good reliability ratings. Because that was the other thing I started looking at, is like, how often is this thing going to break down on me, right? Because if
Yes.
it's going to be expensive, I want to know. So you were, I think, when you and I had talked earlier, you said that there's been some really big shifts in technology in some of the Asian countries that have made their models more efficient, or maybe they're a little ahead of the curve for some of the other companies.
Yes. So what it actually has to do with the cost of the kilowatt. In Europe and Asia, the cost of the kilowatt is driving technology. So for them, the variable speed systems have literally been around for 30 years. Where here in the States, the cost of the kilowatt has not been a driving force. And it still isn't the driving force. It's not the cost of our kilowatt. It's the burden on our power grids that's driving technology. The growth and the available power just is no longer there. So that's what's driving the technology now in the United States, is to decrease overall consumption. So not necessarily the cost of the kilowatt. But when we talk about Europe and Asia, because they are 30 years ahead of us in that technology, a lot of your big American companies, Train, Lennox, Carrier, companies like this, are learning. They're still in the learning process of variable speed. Now they've made leaps and bounds just within the past 5 years. So it's a lot easier to play catch up than to be innovative. And right now they're playing catch up more than they are being innovative. So yes.
Thank you. Maria, one of the things I learned is that Bainbridge Island uses a whole lot of electricity compared to other communities, and that there are definitely some incentives from PSE to help us make the change to some of these more efficient systems. Do you want to say a little about that?
Sure. We have what we call the Flex Smart Plus pilot program, and it's just some really incredible rebates on heat pumps and smart thermostats that are 2 to 3 times the normal rebates anywhere else, because Bainbridge Island is a pilot program area. And I know Rodney is familiar with this as well. I have presented here about the Flex Smart Plus, just about that program, on one of these a few months ago, and have presented elsewhere, and have had community members say to me that they thought it wasn't a real thing until they got this massive check back, and in the form of a rebate related to this. One woman told me she thought her husband was sure they were getting scammed, and then they got this huge check back, a rebate through Flex Smart Plus. So I've been really, Karen Brubeck, who's our community affairs, we've been really trying to get the word out in any way we can about this program, because, as Rodney was saying, one of the reasons Bainbridge Island is one of the pilot program areas is because we would love to see more of our community members become most energy efficient, because it does help with the reliability of our infrastructure here, to be as energy efficient as possible. And that's why the incentive is out there.
I see Rita has a question too. So.
Yes.
So Bainbridge, but what about the rest of Kitsap County? Sorry. Like Silverdale, someplace like that, or other in the outer,
About what programs we have.
There are still programs, yes.
Oh yes, definitely.
Okay.
And John's here, who can speak to the other rebates that are out there related to that. It just, Bainbridge Island is one of the pilot programs for Flex Smart Plus.
Reed's got a question too here.
I'm just wondering, are there specific contractors that are part of the program? And do I need to check on that before I make an agreement with somebody?
So for TDSM specifically, I'll let Maria answer that one. But generally, we have three three categories basically. Contractors that are not participating in PSC rebates. We have what we call trade allies, our trade ally network, and those are contractors that can offer the incentives as an instant, and they've been trained from us. And then we have what we call reps, recommended energy professionals, and these are contractors that have done a high volume of rebates, and then we provide referrals to. So if you give a call to the trade allies or you go through your portal, you can request a referral. It's free to participating contractors. And then to answer the question about rebates really quickly, we have as simply as possible, if you're PSC Electric and there's portions of Kitsap Peninsula that are, and then there are portions that are a Peninsula Lightco, a different utility. And if the primary heat source is currently electric resistance, then we offer $1,500 to go to a heat pump. So if you have a toaster, we'll pay $1,500 for either a ducted or a ductless one for you to get that additional amount. And then just efficiency, to tie into what Rodney was saying, we have an efficiency measure called HSPF, and the electric resistance is 3.4. I forgot exactly what it is, right? So that would be the equivalent would be HSPF, and that's goes off of the kilowatt hours and then BTU output. And our requirements are for a ductless system is 9 HSPF, and then I think it's for ducted 8.5. And so that shows you that, you know, almost tripling of efficiency, right? So for instead of the 3.4 right per kilowatt hour that you're paying for, you're going to get, you know, 9,000 BTUs of heat, and so it's pretty good. Also a little complication on there. You might see this. There's HSPF2 now, which has a little bit lower number, and the AHRI, the organization that we work with to ensure that these are actually efficient equipment, they've recalculated how and are retesting the efficiency of these systems.
As John was saying, our energy advisor service, I put the number in the chat, but I don't think the chat comes through on the video. So 1-800-562-1482 is the number. It's a free service. I always recommend anybody looking at any energy related project in their home to contact our free service. They'll ask you a few questions, ask your zip code, all the usual questions, and give you an idea of what kind of rebates are out there, whether it's through Flex Smart Plus or whether it's through directly through one of our heat pump related programs. If somebody's not in one of our pilot areas, Duval's another area where we're piloting Flex Smart Plus.
Now, with Flex Smart Plus, is that where PSC puts in the smart thermostat and you guys sort of take over the control of the temperature?
If the customer wants to opt into that, we actually pay the customer on an annual basis for participating in what we call our energy, what do they call our energy events. And that's where we would, if the customer does enroll their smart thermostat, that is allowing PSC to raise or lower their heat based on an extreme weather event. The customer can always opt out by manually switching off their thermostat when they know that when they've been contacted by PSC that there's an event coming up. And the events, the event would only take place during the day, during the week. It would never take place on a weekend or a holiday or
Fair
evenings.
And then we have a question from Dinny. How long will the heat pump rebate be out there for customers in Kitsap County?
I don't know of an end for the pilot program, but John, for you?
We have no end date. for rebates. We change it every year. So 1st of January we put out our changes. So keep an eye out for that. But yeah, they're ongoing. No plans to end them.
That's great. Thank you so much. You guys have been incredibly informative. This is wonderful. Anybody, Johanna or Donna or Marcy, do you want to ask anything? Or otherwise, I guess anybody, when any of you panelists have a last minute thing you want to throw out there?
I would love to, if I could have the floor one more time.
You bet.
The rebates, if we think about, yes, it's rebates, you're going to get some money back for doing a thing. There are more than just rebates than just doing your HVAC system. Again, when I talked about the heat load calculation, things like your windows, insulation factors, all impact your heat load and your energy use. There are rebates available out there to improve the energy efficiency of your home in general. So it's not just the HVAC. There's also rebates for windows, for improving insulation factors and things like this. The purpose of the rebate is to make your home more efficient. And that's really the goal, is to make your home more efficient so that you're using less energy.
We've got some great weatherization rebates out there. That's why an energy advisor service looks at the whole, they'll ask questions about everything going on and let you know what's out there with respect to weatherization, windows, all that stuff. So but there really are some really good rates out there right now.
Thank you, everybody. This has been wonderful. And thank you, Anne, for managing the conversation. And thank you for the questions.